Thanks, Jason. Thanks, everyone, for being here. Welcome to the data visualization track of which should be the last one of the conference. Before I get to it, I just wanted to tell you a bit more about myself. So, as an open source developer, as Jason said, I'm a core team member of Project Jupyter. I mostly work on interactive widgets, and I'm the co-author of BQPlot, Py3.js, and iPad leaflet. I'm also a co-author of the C++ extensor and Zeus libraries, and I'm the founder of QuantStack. So QuantStack is a small team of open source developers. We are based in Paris, and we offer services and support for the SciPy stack. We build open source scientific computing software for our clients. And prior to founding QuantStack, I used to be a quant at Bloomberg. I was working at a shouting distance from Jason, who just introduced me. And also, I was an adjunct faculty in math in the math department of Columbia and NYU. Let me give you a quick intro about what widgets are, for those of you who don't know. The initial objective of Jupyter widgets was to reproduce that use case, which is a feature of Sage and Mathematica, which is called interact. And what interact does is that using the introspection features of the Python programming language, you pass it a function, and it deduces the types of the arguments from the default values, and is going to produce a small GUI for you to be able to interact with that function and see the outcome with different values. You can make more complicated examples with interact. Here it's a 2 parameters function, which are real numbers, and produce a very simple GUI, including a plot, a matplotlib plot in the Jupyter Notebook that lets you more quickly explore the behavior of some analysis that you may have done. But in order to produce that, we built something that had a lot more capabilities, the Jupyter Interactive Widgets. And what they are is a special object that, when displayed in the Jupyter Notebook, actually show a graphical component that you can interact with, right? Should you show it twice, both are going to reflect the same state. If you modify the state, the frontend is going to reflect it, and you can read the state from the Python when the frontend was interacted with. So that bidirectional communication is key and is really one of the core ideas of the widgets, and what is enabling most of what I'm going to show after. So you can easily link to widgets with each other, so that you would be able to create small applications with graphical components in the Jupyter Notebook. So the way this works is that when you create a widget object, a counterpart widget model object is created in the frontend that is automatically synchronized. And every time you display it, you have a new widget view displayed in the Jupyter Notebook. And the core widgets package offers a number of controls, like checkboxes, color pickers, etc., for building applications. Although, one thing I really wanted to emphasize here is that more than a collection of controls, actually SciPy widgets is a framework that you can use to build custom visualization. So a couple of years back, I was at the PyData Paris conference, and there was a tutorial on D3.js. And D3.js is a wonderful framework for visualization. There are a number of cool examples online on the Blocks website where you can see an example of a D3.js visualization and the code snippet that can be used to generate that. Essentially copy-pasting that code and tweaking it a bit to wire it with a widgets infrastructure, I was able, in a few hundred lines of Python and JavaScript, to create the exact same visualization inline the Jupyter Notebook. But instead of generating randomly the points here, I can simply feed it with data from the Python kernel. So if you find a great JavaScript library online that produces a plot that none of the plotting packages can produce at the moment, just use SciPy widgets and create a widgets package to bring it to the Jupyter Notebook. We also offer a number of tools to facilitate the packaging of that thing into a Python installable Python package that you can distribute in SciPy and Conda. We built a number of widget libraries on the top of it. One of the first I wanted to mention is SciPy Leaflet. So SciPy Leaflet is a bridge between Jupyter and the Leaflet.js library that allows you to create interactive maps in the Jupyter Notebook. So you can pan, zoom with the map, change the tile layer that is powering the map, or you can start doing things such as using the sidecar widget to display the map in a separate pane so that you don't need to scroll back and forth to see the map being edited as you add things. There are a large number of features into SciPy Leaflet. For example, you can read a GeoJSON dataset and add it to the map. So there you go. Or we support a large number, and also we also support a large number of Leaflet plugins, such as the Velocity one, which allows you to do really cool visualization with like airspeed velocity on the top of a map. And here I re-added the same GeoJSON dataset on the top of it. Should probably remove it. So yeah, that's SciPy Leaflet. If you want to know more about it, you can check out the GitHub repository. It was recently moved to the Jupyter Widgets organization, or just install it from Conda by typing conda install SciPy Leaflet-c conda forge. The second library I wanted to mention before I move on to BQPlot is Py3.js. And just like SciPy Leaflet is a bridge between Jupyter and Leaflet.js, Py3.js is a bridge between Jupyter and the 3.js library. And what it allows you to do is build really fast WebGL 3D visualization in the Jupyter Notebook. It's not really a plotting package. It's more of a scene description package that lets you create anything. So a few years back, I made a lightning talk where I demoed a flight simulator in the Jupyter Notebook built with Py3.js. So it's a fairly generic scene rendering package that you can use to build pretty much anything. Today, one interesting fact about Py3.js is that most of the code in Python and JavaScript is actually generated from a JSON spec that is actually describing all of the widgets that exist in the framework. And there are many others. One that is of interest for this community is probably Jupyter Matplotlib. As you know, Matplotlib is a Python package for visualization, probably the most popular Python package for visualization, and it does the rendering in the backend. So it's not really amenable to web use, but using SciPy MPR or Jupyter Matplotlib, you can bring the interaction of Matplotlib to the Jupyter Notebook. And here I have interactive Matplotlib figures in Jupyter Lab. So you can find the Jupyter Matplotlib project on Conda Forge, and it's on the Matplotlib organization on GitHub. Another example of it, of a library, it's SciPy Volume. I'm not going to say much about it because there is a full talk right after my talk about SciPy Volume. I'm just going to show a really pretty 3D plot as a teaser. So stay in this room after my talk and attend the talk of Martin. SciPy Volume is awesome. And there are many others, like NGL View for visualizations of proteins and molecules. So BQPlot. So what BQPlot is a Jupyter D3.js bridge. So it's also open source, Apache licensed. And it implements the abstractions of Wilkinson's grammar of graphics as interactive Jupyter widgets. So we provide a PyPlot-like API that lets you make simple plots like a line chart, scatter plots. All of these are interactive, so you can pan zoom very easily. Histograms, maps. We do allow pie chart, even though we're a grammar of graphics package. Heat maps, and in the next release, actually, BQPlot is going to support the Viridis and all of the other Matplotlib color skills. Thank you. Every component of a BQPlot figure is a widget. So for example, instead of using these high-level routines of PyPlot to compose a chart, you can assemble a chart yourself by using the the constructs of the grammar of graphics, such as scales, axes, marks. Should you change the attributes of a plot, like the y attribute of a lines is going to be reflected visually right away in the plot. And scales and domains are going to update automatically. Same goes for pretty much anything. Here, this is a scatter plot. Updating x and y is going to be reflected right away. I can change other properties, such as the type of marker and their colors, and everything can be animated. The same holds for attributes of scales and axes. Here, I set the minimum of a scale to 4. And again, it's going to, I should probably create a new view for that thing so that I don't need to scroll back and forth. If I set the minimum to 6, it's going to update the plot, set it back to none, it's again computed from the data. I can edit the chart incrementally with legends and whatever you want. Scales are really at the center of the grammar of graphics constructs. So here I'm, like, for example, using two plots that make use of the same y scale, but the different x scales. So on the left-hand side, you have very different order, and right-hand side, you have very different order of magnitudes for the x scales. But they are plotted on the same y scale so that you can compare them. And the domain of that scale is based on the union of the data sets that were plotted using that scale. Should I move one of the data set, all the figures are going to be updated, reflecting the new domain. You can use BQPlot figures as input widgets. So for example, in that case, I am using a fast interval selector, which is a sort of selector that widens when you move the mouse up and shrinks when you move the mouse down. And the horizontal position of the mouse controls the center position of the interval. And obviously, the selected attributes of all the marks on the figure are updated every time you move the selector. You can change the interval selector, and now in the latest version, you can have vertical selectors, and this one is a different type. It's a like very classic brush interval selector. Or we can have lasso and other things. In this example, I'm showing another example of an interaction, which is drawing on figures. Just like in the case of interact, should you have an analysis that depends on a function parameter, you can just draw that function instead of trying to compose it manually with signs and linear components and exponentials. So if you want to see the outcome of your analysis with that shape, just draw it in the notebook, and it's going to be reflected in all the maps that are bound with it. You can also move points around in scatter plots and have callbacks reflect that change. So that's basic introduction to BQPlot. BQPlot was used to make a number of applications. So here I'm going to show a recreation of Mike Bostock's Wealth of Nation. So I'm just going to execute all of the cells, which are a few hundred lines. And this small resulting application is merely a chart with a slider and a play button so that you can easily animate. So it's a scatter plot of the life expectancy versus income per capita for all the countries of the world, or a number of countries of the world. You can manually change the date, or pause it, hover on a country, and see what that country is. The size of the bubble corresponds to the population. Since BQPlot, SciPy leaflet, Python.js, SciPy volume are built upon widget, they are really easily to interpret because they are built on the same foundation. Here, this example here is an application that we built during a 24 hours hackathon called the Base Hack in San Francisco. And using SciPy leaflet and BQPlot, we put together that small visualization where whenever you hover on a zip code in San Francisco, you see a plot corresponding to different features of that neighborhood. So the goal of that study was to try to explain the level of satisfaction of self-assessed level of satisfaction of residents of a neighborhood based on predictors, which are actual features of these neighborhoods. Quality of environment, availability of labor, cost of housing, average distance to a restaurant. Right. People seem to be pretty happy in that area. But I don't know San Francisco. I wouldn't know about it. Other examples of applications, maybe I should talk about the mobile lawsuit patent example, which is a recreation from another visualization by Mike Bostock. If you hover on Apple, you see that there are a number of lawsuits involving Apple. So Samsung and Apple are both suing each other. Kodak is suing Apple, etc., etc. So you can create this sort of nice applications using BQPlot fairly easily. What about big data? So one of the limitations for a long time of BQPlot is that since we were based on the SVG, we could not make scatter plots or visualizations of very large data sets. So this is changing. The next version is going to have the mega marks. And by mega, I mean that we can display marks and new types of scatters that involve a lot of points. So this is not yet in released, but I'm using the latest version from master right here. So here, this is a simple scatter plot of 100 points. So let's try to change it to be 1,000 points. All right, that still works, right? Let's do 10,000 points, right? Still very smooth, right? Let's go 100,000, right? That works. It was a bit longer. Let's go 1 million. So here, this is taking a bit more time. The only reason is that we're still serializing that million data points in JSON, but now the widgets infrastructure allows us to serialize using binary formats that should make it really faster. And well, this is already in use in SciPy volume, so you're going to see that in the next talk by Martin. There you go, 1 million points. So yeah, now you can display big data sets, bigger data sets in BQPlot. What if you want to go even beyond millions of points? So I don't have much time, but I'm going to really quickly show Vex, which is a data decimation engine. Or maybe I should show this actually in the classic notebook. And okay, live demos. Okay, I won't show the Vex dataset today. It was working right before the talk. I'm sorry about that. How much time do I have? Like maybe 3 minutes. Okay. Before the end of the talk, I just wanted to talk a bit, present a bit what's coming in the widgets world, and especially for BQPlot, with a project called Zeus. And what Zeus is, it's a C++ implementation of Jupyter protocol. It's not a kernel itself, but it's a tool that can be used to make kernels easier. And with this, we actually made a number of kernels, an R kernel as well as a C++ kernel using the C++ interpreter from CERN. So here is a quick demo of the C++ kernel at play. We're displaying data, throwing errors, interpreting the C++ languages, including functions, classes, doing polymorphism, templates, pretty much anything. We can use the rich data display we can use the rich data display features of the Jupyter Notebook in C++ for whatever MIME types are supported by the front end. So I hope you appreciate that this is compiled code. It's being compiled on the fly for every cell. So it's not a natural thing to do for in C++. And then we built upon this and wrote a backend for the Jupyter widgets infrastructure called X-Widgets, which allows you to create widgets in C++. Okay, it seems that my notebook server is dead. Okay. Seems that I'm unlucky today. Well, I don't know what's going on. Well, I think this is the end of the live demo. I'll be taking questions from here. Questions?
We have a mic up here. I can walk a mic around.
Is there any way for the widgets that you're creating with BQPlot to export the code or export them to be embedded into a website without having Jupyter running?
Absolutely. So there are multiple ways to do this. As a quick example, I can show you the Jupyter.org website. On the widgets page on the website, you will see a number of widgets live here, right? So here's an SciPy leaflet map. There is a BQPlot chart here that's live, right? So you can display live widgets on web pages, in the documentation, pretty much anywhere. Although in this case, you don't have the interactions with the kernel, right? So there are other solutions to include interaction with the kernel that are varied, either using Binder or any server able to provide a kernel backend.
Other questions?
Yeah, there is a mic right here.
So follow up. Turn it on.
Yeah. So follow up to the last one. If you take one of those pieces out, does it need to call out to other libraries or things on the internet or some kind of Jupyter server, or is it all self-contained within that page?
So the JavaScript is going to be fetched from a CDN. So you just need to include a script tag to your page that you don't need to host, and you're going to have that on your page. In the classic Jupyter Notebook, if you open if you display a few widgets like this, well, hopefully my kernel is back. I don't know what happened to my notebook server, but this never happened to me before. But anyways, there is a menu here for widgets that lets you embed widgets. And what this produces is an embeddable HTML snippet that you can put onto any HTML page.
Ah, okay.
Yeah.
Thanks.
Yeah.
Yeah, just to thank you for making Zeus available. We started to integrate that in our project, and it works very well. There's a minimum set of dependency, and the community is very reactive. After the same day, we submitted some PR, and we got them integrated, and it's an awesome project. That's it.
Thanks.
Any other questions or ringing endorsements?
So my notebook server crashed earlier, but I just wanted to show this. This is a C++ notebook, including a X leaflet visualization, which is a backend to SciPy leaflet. We are now writing backends to all of the main widget libraries, including BQPlot, Py3.js, SciPy volume, and all of them in C++. And the goal is to, through Zeus, expose this to all the languages of data science, including Julia, R, etc. So really enable the widgets in a cross-language fashion.
We have time for maybe 2 or 3 more questions before the break. Any other questions? All right, we have a 30-minute break. Oh, one question.
Yeah, hey, Great talk. So, what was the motivation for the Zeus project supporting C++ in an interactive fashion? I mean, where did that come from?
So why C++? This comes from a more general approach that we're having for a lot of the projects we have at QuantStack. In our opinion, C++ is sort of the common denominator between R, Python, and Julia. So writing things once and making bindings to these languages is a good way to not duplicate the implementation for many programming languages, be it for protocol implementation, data structures, all of that. You can do the job only once, right? So Zeus is that implementation of Jupyter protocol. And we wanted to showcase Zeus in a non-trivial fashion. And we found that project that comes out of CERN called Cling. It's a C++ interpreter that we wrapped as a kernel with Zeus. There are other kernels being built right now with Zeus. One is the Juniper kernel. It's a R kernel that supports widgets by Spencer Ariello. And there is another project out of from Kitware. It's actually a Python kernel built with Zeus. And the reason why they didn't use the classical implementation of SciPy kernel, like the reference implementation of the Jupyter kernel protocol, is that because Zeus has a different model for concurrency that allows you to, for example, process control messages as you're running code, or to integrate into event loops and things like this. Yeah.
All right. Any other questions? All right, we have a 30-minute break, and
Thank you.
Martin Brettles will be talking at 3:30.